Linked list. Linked list is a linear data structure where elements are stored as a sequence of nodes. But the sequence of nodes do not require contiguous memory allocation. When we learned about arrays, I told you that arrays require contiguous memory allocation. I also told you that whenever a design is done in some particular manner, there will always be a reason why it is done this way. Why are arrays designed this way? Why is it that they always need contiguous memory allocation? The reason is efficient access. Because of contiguous memory allocation, arrays are able to provide you with efficient access. When I told you that linked lists do not need contiguous allocation, it is implied that efficient access is anyway not possible. Then the question is, why are linked lists implied this way? Why are they implemented in a way that they do not require contiguous memory allocation? Again, whenever a design is done in some particular manner, there has to be a reason. What is the reason here? Linked list can dynamically grow and dynamically shrink. Arrays cannot do this. Arrays cannot dynamically grow or shrink. We are not talking about dynamical arrays. We are only talking about the static ones. Comparing those with linked list can grow and shrink dynamically. What will each node of a linked list contain? Each node will contain data, that is whatever information you want to keep in the linked list, and a pointer which will be pointing to the next node. Those are these pointers. They will tell you what is the location of the next node. For example, if this is the memory you are having, linked list node can be present anywhere. It need not be contiguously present. One node can be here, the next node can be here, next one can be here. But how are they linked? From the first node, you will have a link which is pointing to second node. From the second node, you will have a link which is pointing to the third node. This is how all the nodes of a linked list are connected. You can imagine it something like this. You are playing a treasure hunt. How do you generally play a treasure hunt? Whenever you are playing a treasure hunt, you will initially only know about the starting point, whichever be the starting point. Consider that there is a cave and this cave is your starting point. You don't know which is the second location, third location or your destination. From here, you will get a clue. Using the clue, you will identify which is the second location. Let us say this clue told you that the second clue is present near a tree. Then you reached a tree which is somewhere near this, and under this tree you found the second clue. Till the point you picked this clue, you had no idea of where the second clue is present. But this directed you towards the second clue. Till you get this clue, you have no idea of where is the third clue. But let us say this clue told you that the third clue is present in a building nearby. So you reach the building. Once you reach this building, you were able to get the third clue. The third clue will tell you, let us say fourth one is the final destination. The final destination was directed by the third clue. This is how a treasure hunt works. The same way in a linked list, till the point you reach the first node, you have no idea of where the second node or third node is. If you want to go to the second node, you have to come to the first node, then follow the link and reach the second node. Similarly, if you want to reach the third one, you have to, in treasure hunt, you have to pick this clue. Then according to the clue, you will navigate and reach the third clue. In linked list, you have to reach the second node. From there, you have to follow the pointer. The pointer will take you to the third node. So this is how you can imagine a linked list. If you imagine it like a treasure hunt, it is easier to understand. Do not imagine it sequentially, because you need to understand that even though we generally draw it sequentially, it is not actually present sequentially in the memory. In memory, it will be present here and there, but the link will help you to join all those. This is the point. Next thing is it just this, the linked list, or linked list can be in many forms? It seems that linked lists can be in many other forms as well. What we just learned, this is called as singly linked list. What is a singly linked list? A singly linked list will have a node, then every node will have data and a pointer to the next node. There is a single pointer, that is why we are calling it a singly linked list. So there can be many nodes in this, but every node will have only one pointer which will point to the next node. What is the drawback? The drawback is that if you want to traverse through this list, there is only one direction in which you can traverse. You can start from this and go in this direction. The reason is you only have the links in one direction. What about the other type of linked list? There is something called as doubly linked list. Whatever we already learned, this is a singly linked list. What is doubly linked list? In case of doubly linked list, each node will be having two pointers. So this one will have one pointer will point to the next node and one pointer which will point to the previous node. This doesn't have a previous node, so this will be null. But coming to any other node, one will point to the next node, one will point to the previous node. If you take this node, one will point to the next node, one will point to the previous node. Similarly, if you take this node, there is no next pointer, so this is null, but the previous pointer will be present for this. What is the advantage here? In case of doubly linked list, you can traverse in both the directions. Each node will have one pointer which is pointing to the next node and one pointer which is pointing to the previous node. And the advantage is traversal in both directions. There is one more type of linked list which is called as circular linked list. What is the speciality of a circular linked list? This is very similar to what we already learned about linked list. Let us say there are three nodes. This is how your singly linked list will look like. For a circular linked list, there is a slight difference. The difference is that whichever is your last node, that will have a pointer which will point to your first node. Because of this, it is called circular. It can travel in circular manner. This can be either a singly linked list, can also be a doubly linked list. But generally, in a circular linked list, we'll use single linked list. Okay. In a singly linked list, the only difference between a normal singly linked list and a circular linked list is that the last node, whichever be the last node, that will have a pointer which is pointing to the head node, that is the first node. This is the only difference. So we learned about singly linked list, doubly linked list and circular linked list. We'll learn in detail about all these and all the operations in the coming lectures. For now, we are just getting an introduction to all of these. Okay. Next thing is, what are the advantages of a linked list? We already learned about arrays. Linked list are the second data structure we are learning. What are the advantages of a linked list? Advantages, first thing we already learned. What is it? It is dynamic size. Because of dynamic size, what is the advantage? It can easily grow. It can easily shrink. This is the advantage. In other words, you can say insertions are efficient, deletions are efficient. You can at any point insert a new node easily. You can delete any node easily. In an array, if you remember the previous lectures, array size was already predefined. Even if you remove any element or you add an element, the total memory that is allocated for the array, that used to remain the same. But in case of linked list, you can dynamically allocate, you can dynamically deallocate. This is the advantage of a linked list. Whenever there are advantages, there has to be some disadvantages. So what are the disadvantages of a linked list? The first disadvantage is memory overhead. How is this memory overhead occurring in a linked list? The reason is, I told you that every node will contain data, and along with data, it will also have a pointer. This pointer will tell you where the next node is present. This also means you are wasting memory for a pointer. Whenever you want to store data, if this was an array, you don't need any pointer. You could have directly stored data in next blocks. But here, because you have a pointer, you are using extra memory for this pointer. So this is a memory overhead. What is the second disadvantage? Second disadvantage is what we learned as an advantage for arrays. For arrays, we told efficient access is an advantage, and coming to linked list, the problem is whenever you want to access any element, you have to do sequential access. What is the reason? We already learned that if you want to, let us say, go to the fourth node, you can't directly go to the fourth node. Instead, you have to go to the first node. First node will tell you where is the second node. Second node will tell you where is the third node. And that will tell you where is the fourth node. This is where we took that treasure hunt example and understood how this is working. So I want you to picturize each data structure differently so that whenever you are thinking about a problem and a solution, you should be able to suddenly connect that this is the purpose, this is the requirement, and accordingly, this is the data structure that I need. This is the whole point of learning all these. One more thing before we conclude this lecture, you should also know where to use this linked list. You learned about linked list, you learned how it is working. You should also know where to apply this. What are the use cases? So use cases, one thing is you can say any application where you want to frequently do insertions and deletions. This is where linked list is generally used because it allows for efficient insertion, efficient deletion. Because of this reason, one application is you can say anything which requires frequent insertions and deletions. Second thing is linked list is used for implementing other data structures. With arrays also we had seen this. Coming to linked list, if you want to implement stacks, queues or anything, you can implement it using linked list. This is an option. Then for managing memory, sometimes you use linked list for managing memory. Why is it used? It is because you may have a lot of chunks of memory and some memory may get freed at any point. So you can have one linked list which will tell you which are the memory in use and another linked list which will tell you these are the memory blocks which are free. So what happens when some memory block gets freed? You can just add that to the linked list of freed memory blocks. This is how it is used for managing memory in low-level programming. We'll see many more uses of linked list as we go forward. So this is basic about linked list. In the coming lectures, we'll see what are the operations on a linked list. That is how to insert in a linked list, how to delete from a linked list, how to search in a linked list, what are the different operations. We'll see about all of those in detail.